There is a farmhouse in Lancaster County, Pennsylvania, where the kitchen faucet runs cold, clean water every single day. No hum of an electric pump, no pressure tank in the basement, no wiring running to a well casing. I stood in that kitchen on a Tuesday in March, turned the handle, and watched the water flow. Steady, clear, cold enough to sting. I asked the owner what his water bill was. He looked at me like I'd asked him a strange question. He said he had never had one. Not once. Not in 41 years of living in that house. The system that delivers his water cost him $12 in plumbing fittings. It has no moving parts that require electricity, no motor, no circuit breaker, and it has not been repaired or replaced since 1983. That is not a fairy tale. That is a Tuesday in Amish country. And here's what stopped me cold. The average American homeowner with a well spends between $900 and $4,000 just to install a well pump. That does not include the pressure tank, the wiring, the electrician, or the permits. That is just the pump. And that pump, on average, lasts 8 to 15 years before it fails and needs to be replaced. So you are not paying once. You are paying again and again and again, every decade or so, for the privilege of pulling water out of the ground that the earth is already trying to give you for free. But the cost does not stop at installation. An average residential well pump uses somewhere between 700 and 1,500 watts. Run it 8 hours a day at the national average electricity rate, and you are looking at $40 to $80 a month. That is $480 to $960 a year, just to move water. Over 30 years, the electricity alone can cost you $14,000 to $28,000. Add in 2 or 3 pump replacements at $2,000 to $4,000 each, you are looking at $20,000 to $40,000 over the life of a mortgage, spent on something that a $12 arrangement of pipe and gravity does for nothing. And the question that kept turning over in my mind on the drive home was this: what if the most reliable water delivery system ever designed was perfected centuries ago, and the only reason you are not using it is because no one can sell you a replacement part? Let me walk you through exactly how this works, because the physics is not complicated. It is just invisible, unless someone shows you. On number 1, the gravity-fed spring capture. This is the foundation, the bedrock, literally and figuratively, and it is the simplest idea you will encounter today. Groundwater, in most of the eastern United States, reaches the surface through natural springs. That water comes out of the earth at a remarkably consistent temperature, year-round, between 45 and 57 degrees Fahrenheit. It does not matter if it is July or January. The earth below the frost line holds that temperature steady, and the spring water carries it to the surface. The Amish figured out something that colonial settlers in Pennsylvania knew as early as the 1700s. If your spring is at a higher elevation than your house, you do not need a pump, you need a pipe. Water flows downhill. That is not engineering, that is gravity. And gravity does not send you a bill. The physics here is straightforward. For every foot of vertical drop between your water source and the point of delivery, you gain approximately 0.43 pounds per square inch of pressure. A spring that sits just 20 feet above your kitchen sink gives you 8.6 psi of static pressure. That is not a lot by municipal standards, but it is more than enough to run a faucet, fill a bathtub, and supply a household. 40 feet of elevation gives you over 17 psi. Some Amish homes I visited had spring sources 60 to 80 feet above the house. That is 25 to 34 psi. You will not run a fire hose with that, but you will run a home. The Persians understood this 3,000 years ago. They built underground water channels called qanats, gravity-fed tunnels that tapped mountain aquifers and carried water for miles across arid deserts, all without a single pump, using nothing but the slope of the earth. Some of those systems are still functioning today. Over 22,000 qanats remain operational in Iran, spanning more than 170,000 miles of underground channels. The Romans borrowed the same principle for their aqueducts. They moved water across entire empires using gravity alone. Not one of those 11 aqueducts that served ancient Rome had a motor. And yet the city of over 1 million people had water in their fountains, their baths, and their homes. The Amish did not invent this. They preserved it. And there is a difference that matters. But that is only half the story. On number 2, the spring house. Before refrigerators, before ice delivery, before anyone ran copper wire into a farmhouse, there was the spring house. And what it does is almost embarrassingly simple. A spring house is a small stone structure, usually about 10 feet on a side, built directly over or adjacent to a natural spring. The water flows into a stone-lined pool or channel inside the structure, and then flows out the other side into a small stream. The interior stays cool year-round, because the water temperature holds steady around 50 degrees Fahrenheit. In summer, the spring house was a natural refrigerator. Milk, butter, eggs, cheese, and vegetables were placed in sealed crocks and partially submerged in the flowing water. In winter, the relatively warm spring water kept the interior above freezing, protecting stored food from frost damage. The Pennsylvania Historical and Museum Commission has documented spring houses across the state that have been in continuous use since the colonial era. Some of them are older than the Constitution, and here is what made me stop and think. The Amish family I visited does not just use the spring house for food storage. The spring water flows from the spring house through a buried pipe downhill to the main house, where it enters the kitchen and bathroom. No pump, no tank, no electricity. The pipe was standard half-inch galvanized steel when it was originally installed. Some families have since replaced it with Schedule 40 PVC. The cost of the pipe and fittings in many of these systems totals somewhere between $12 and $50, depending on the distance from the spring house to the home. That is the entire water system. That is the whole thing. Now here's where most people stop. They hear gravity-fed spring water and they think, well, that only works if you have a spring, and many people do not. But stay with me, because the next technique changes the equation entirely. On number 3, the hydraulic ram pump. This is the piece that made me feel like I had been lied to my entire life. A hydraulic ram pump moves water uphill, without electricity, without fuel, and without any external power source whatsoever. It runs 24 hours a day, 7 days a week, 365 days a year. And it has only 2 moving parts. Joseph Michel Montgolfier, the same Frenchman famous for co-inventing the hot air balloon, built the first self-acting hydraulic ram pump in 1796 for his paper mill in Voiron, France. His friend, Matthew Boulton, patented it in Britain a year later. By the mid-1800s, these pumps were common across rural America. Cast-iron ram pumps made by companies like Rife and Gould's were standard equipment on farms from Pennsylvania to Montana. I spoke with a man whose grandfather ran a dairy farm using a ram pump that was already working when his grandfather bought the property in 1940. It supplied water to the house and barn for over 30 years. No electricity, no fuel, just the sound of water hammering rhythmically through the pipes, day and night. Here is how it works, in plain language. Water flows from a source, a spring or creek, down a pipe to the ram pump. The flowing water builds speed and escapes through an open waste valve. When the water is moving fast enough, the force slams the waste valve shut. All that momentum has to go somewhere. It creates a pressure spike, a water hammer, that forces a small portion of the water through a second valve and up into a delivery pipe. That delivery pipe carries the water uphill to a holding tank, a house, a barn, wherever you need it. After the pressure spike dissipates, the waste valve opens again, and the cycle starts over. This happens 40 to 90 times per minute, automatically, indefinitely. The ratio is roughly 1 to 7. For every 1 foot of water falling into the pump, you get 7 feet of lift out. A stream with just 3 feet of drop can push water 20 feet uphill. 5 feet of drop can push water 35 feet up. Clemson University Cooperative Extension has published detailed construction plans for a homemade PVC ram pump that costs between $120 and $200 in fittings. Their testing showed output of about 1/3 of a gallon per minute with 10 psi of operating pressure. That adds up to over 400 gallons a day. A rancher in Deer Lodge, Montana, built 2 ram pumps based on Clemson's designs. One lifts water 36 feet and pushes it 900 feet. The other lifts water 90 feet and pushes it 700 feet. Both made from PVC fittings glued together in an afternoon. 0 operating cost. He has been running them for years. And here's the thing that should make you angry. These pumps were everywhere in rural America in the 1800s. By the late 1800s, interest waned as electric motors became widely available. The plumbing industry did not ban ram pumps. They did something more effective. They made them irrelevant by requirement. Building codes began mandating minimum pressure standards, licensed electrical connections, and certified pump equipment that only an authorized contractor could install. A gravity-fed system, or a ram pump that had supplied a family for decades, suddenly could not pass inspection. Not because it failed, but because it was not on the approved list. The Plumbing, Heating, Cooling Contractors National Association has been operating since 1883. They are the oldest trade association in the construction industry. Their stated mission includes championing regulations and codes at state legislatures. The International Association of Plumbing and Mechanical Officials, known as IAPMO, has been setting plumbing codes since 1926. When you look at the Uniform Plumbing Code, you will find extensive sections on approved pump types, required pressure ratings, licensed installation standards, and mandatory inspections. What you will not find is a section on gravity-fed water systems, or hydraulic ram pumps, or spring-fed household supply. That is not a conspiracy. That is just a market that rewards complexity and punishes simplicity. Every well pump installed is an electrician's bill, a plumber's bill, a permit fee, an inspection fee, and a future replacement sale. A gravity pipe from a spring to a kitchen generates exactly $0 in recurring revenue for anyone. I will let you draw your own conclusions. On number 4, the integrated spring-to-household system. This is where the Amish combine all of the above into something that, frankly, makes the modern well and pump system look like an over-engineered money pit. The full system works like this. A spring is captured at its source and directed into a spring house. From the spring house, a buried pipe carries the water downhill to the main residence. If the spring is not at a sufficient elevation above the house, a hydraulic ram pump, driven by a nearby creek, provides the lift needed to move the water to a holding tank, or cistern, positioned above the house. From that elevated tank, gravity carries the water down into the household plumbing. The holding tank acts as both a reservoir and a pressure source. A standard food-grade IBC tote, the kind you can buy used for $30 at a farm supply store, holds 275 gallons. Mounted on a simple platform or hillside, even 10 feet above the fixtures, it provides over 4 psi of pressure. Stack 2 totes. Build the platform 20 feet high. Now you have real household pressure with no pump and no power. The entire cost of this system, depending on the distance from water source to home and the materials used, ranges from $12 for the simplest spring-to-pipe connection to maybe $300 or $400 for a full ram pump and elevated cistern installation. Compare that to the average well pump installation cost of $900 to $4,000, plus $50 to $80 a month in electricity, plus replacement every 10 to 15 years. Over 30 years, one system costs you $1,200 to $400 once. The other costs you $20,000 or more, and it stops working the moment the power goes out. Now, if you already own a house and you are thinking this only applies to people building from scratch or living on a farm, stay with me, because this next part is specifically for you. On number 5, the retrofit. A couple in rural Oregon had a 1,500 square foot house built in 1987 with a standard submersible well pump. Their electricity bill for just the pump averaged $62 a month. They had a small creek running through their property with about 4 feet of drop over a 40-foot stretch. They installed a homemade hydraulic ram pump for under $200, piped the water to a 1,000-gallon tank they mounted on a hillside behind their house, and ran PVC pipe from the tank into their existing plumbing. They did not remove the well pump. It is still there. They just never turned it on. Their water runs by gravity now. Their pump electricity cost went to zero overnight. You do not need a spring on your property to benefit from these principles. If you have any elevation on your property, even a gentle hill, you can set up a rainwater catchment system that feeds into an elevated holding tank. From that tank, gravity delivers water to a garden, a workshop, a livestock trough, or even a secondary household line for non-potable use. A simple rainwater system with 55-gallon drums on a 12-foot platform costs under $150 and provides enough pressure to run a drip irrigation system all summer with zero electricity. The easiest retrofit, the one you could do this weekend, is to set up a gravity-fed outdoor water station. An IBC tote on a 4-foot platform filled by a garden hose or rainwater with a standard spigot at the bottom. You will get about 1.7 pounds per square inch of pressure. That is enough for a garden hose, a livestock waterer, or an outdoor wash station. No pump, no wiring, no permit needed. Total cost, under $50. The next level is an elevated cistern fed by your existing well pump during off-peak electricity hours. Fill a large tank once, then use gravity to distribute throughout the day. You cut your pump's runtime in half, extend its life, and halve your electricity cost. No new construction, no tearing anything out, just adding a tank. And for those with a creek or spring on or near their property, the ram pump is the answer that should have been obvious all along. Clemson, the University of Georgia, and North Carolina Cooperative Extension have all published free public construction guides. The materials cost under $200. The operating cost is zero. Forever. But the piece that truly stopped me cold, the thing I have never seen in a single modern plumbing guide, is this. On number 6. The Buried Secret. I came across a reference in a 1938 USDA Farmer's Bulletin on farmstead water supply that described, in precise detail, a method for pressurizing a gravity-fed household water system using nothing but the thermal expansion of water in a sealed, buried pipe run. The technique involved running the supply pipe in a specific serpentine pattern through a sun-exposed area before it entered the house. As the water inside the exposed section warmed by even a few degrees during daylight hours, the thermal expansion in the sealed section created a modest but measurable pressure boost, enough to push water through standard household fixtures without any mechanical assistance. The principle is simple thermodynamics. Water expands as it warms. In a closed system, that expansion has nowhere to go except forward. A temperature increase of just 10 degrees Fahrenheit in a 100-foot run of 1-inch pipe creates measurable pressure. It is not a lot, but combined with gravity head from even a modest elevation difference, it pushes a marginal system into a fully functional one. The additional cost is zero. You are just routing the pipe you already need through a sunny patch of ground before it enters the house. And that detail, that one small addition, was the difference between a gravity system that worked adequately and one that worked like a pressurized municipal supply. That bulletin was part of a series that was quietly discontinued in the 1950s, as rural electrification made such techniques seem obsolete. The techniques were not disproven. They were not replaced by something better. They were simply no longer promoted. One generation stopped teaching them. The next generation never learned they existed. I have been sitting with that for a long time. Here is what I keep coming back to. $20,000 to $40,000 over the life of a mortgage, or $1,200 to $200 once. That is the math. And it is not even close. What you and I now share is something that an entire industry of pump manufacturers, electricians, plumbing contractors, and code enforcement boards has a financial interest in you never learning. Not because they are evil, not because there is a shadowy conspiracy, but because every gravity-fed pipe installed is a well pump that never gets sold. Every ram pump glued together in a garage is an electrician who never gets called. Every spring house that keeps running for 40 years is a repair invoice that never gets written. What cannot be sold cannot generate revenue. What cannot generate revenue cannot be advertised. And what is not advertised disappears from public knowledge, one generation at a time. After the last video, hundreds of you asked where you could find all of these methods in one place. So I put together a complete guide with detailed instructions, material lists, and pressure calculations for every system I have covered. The link is in the description. Here is what I want from you. If you have a spring on your property, or a creek, or even just a hill, drop your state in the comments and tell me what you are currently paying for water, or for electricity to pump water. I want to build a map of what these systems could save across every state in the country. And if your grandfather or great-grandfather ever had a spring house or a ram pump, I want to hear that story. Because those stories are the proof that this knowledge was not lost. It was just quietly set aside. Next week, I am going to show you the Amish food preservation system that has kept produce edible for over 9 months with no electricity and no canning. There is a 1903 USDA survey document that maps every root cellar design used across 17 states. What is in that document could cut your grocery bill by 40%. And you have never seen it because it has been out of print since 1961. If you are the kind of person who believes real knowledge has been quietly pushed aside to protect someone else's profit, you already know what to do. I will see you next week, and I will have that document with me.